Thanks for tuning in. If you are a first time visitor, please do subscribe our channel. Like this video to show your support. Comment below with your thoughts, questions and suggestions. In this video, we are going to discuss about switching from schematic to PCB board, that is part 1. So we will discuss in detail what are the topics we will cover in the video. So first thing, we will learn about creating the new project. How do we create a new project in OrCAD Schematic? And then we will create the symbol preparation. So we got the 3 different types of symbol. So one is we will use it from the existing library, or we will download the symbol, or we will create it on our own. And then we will see about a schematic preparation. Along with that, we also download the footprint from the third-party websites. So we will also download the 3D of the component, 3D step mapping of the component, and then we will map 3D to our downloaded footprint. Once after this, we will do creating netlist or exporting the netlist from the schematic, and then we will create a fresh PCB board, the new PCB board, and then we will import the created netlist into the PCB board. And then we will do the component placement, and we will see how it looks like in board design, that is placement, that is 2D, and the 3D view of the PCB. And also we will do multiple components, and then we will see how do we switch from the schematic to PCB board and from board to 3D view. We have an important update for you. If you guys are looking for a PCB design course from basics to expert level, we have it for you. This is an Udemy course, PCB design in Cadence OrCAD Allegro, basics to expert level. This course has got 3,800 plus students enrolled and has got 4.5 rating. So this particular course has got 33.5 hours on demand video and 151 downloadable resources. And also this course has got 16 different sections with 154 lecturers plus counting. That means we are updating classes every day or every week and basis. So if you want to opt to this course, it is just an affordable price. You can go for this. I will leave this link in the description box. If you are interested, please go through it. If somebody else is interested, please share with them. Thank you. Let's begin creating the new project. So I will create a folders before creating a fresh new project in your schematic. So I'll right click on the desktop. I'll choose the desktop as my location, so you can choose any other drives on your PC. Right click, select new and folder. I'd say this is switching project. I give the name of the project as switching project. Open it, and inside that I would like to create another folder called schematic. So we will be having different things like schematic, symbol preparation, footprint preparation, so you can create folders accordingly. So now I am going to create schematic folder. Inside that we'll create a schematic in OrCAD. So this is a file system we create in any location you want on your PC. So I just created it on desktop, which is switching project. Inside that we will create the schematic folder. Inside the schematic folder we'll create a fresh new project in OrCAD. So now open Capture CIS, go to start, click on Capture CIS, open Capture CIS. Inside the first option, that is OrCAD Capture, you can select it and then click OK. So we're creating the new project, so we'll go to File and select New Project. So otherwise we have the new design, a new project direct links here for getting started. You can use that also. So we'll go to File here, New, and click on the project. So you got the pop-up, small pop-up where it asks you give the name of the project. So I will give that project name is switching project. So we are switching from schematic to PCB board. So we'll create switching project as a name, and the location where we created the folder, we'll click on the browse button, go to desktop, go to switching project folder, go to schematic and select this particular folder and click on the select folder. So this is the location, and then click on OK. As soon as you click on OK, so there is a new project will be created, and the new sheet is also created automatically, and it will open. So before proceeding with this, we will see that what is created inside the folder which we created. So we'll go back to our folder section, go to schematic and open it, and you can see this switching project.dsn, which is our main project file, so which is created inside the schematic. And now we will have some setups in getting started with schematic. First thing, the sheet, you can see you can name the sheet. So on the left side panel on the DSN, you double click on the DSN, you can see schematic, double click on the schematic, and we have the page 1 option. So right click on the page 1, you can rename the particular page. I'll like to give project that is switching project. This way also you can give. So usually we use it for whatever circuit we create inside this particular page 1, so accordingly we name it. So here I have just give the name as switching project. So double click, this is the title block. Here you can even change the title. I'll add some like components for adding, so I just give the same name like switching. Okay, that's fine. And also, so this is about how to change the name of the page 1, and you can go to options here, go to schematic page property. I would like to choose millimeters and A4 sheet for a better viewing option. So click OK. Now you can see this is A4 sheet. You can also take a quick printout in A4 sheet, so we will most of the time choose A4 sheet, or whichever sheet is asked to take, please choose that particular sheet. So this is how we are going to create a project, a fresh new project. And with this project we are going to create a symbols, and we'll add the symbols, and then we'll add the schematic, footprints, and we will switch to PCB. So this is the first step. We are creating the fresh new project, and we have some project settings. Now we are going to discuss about how to create the symbol, or how to download the symbol, or how to use the existing library. So as I told you, there are 3 different ways we can use the symbol. First thing, use the library, which is the existing library in the Cadence tool. You can use the symbols using those libraries. If you don't find the required libraries, you can download it from the internet. You can download the libraries and you can use those symbols. And otherwise, if you don't get an internet also, so finally you have an option to create the library and you can use it. On a quickly note, we will see all 3 types. First we'll use the existing library, second thing we will download the library, and third thing we'll create it. So let us discuss about using the existing symbols. I will take a place option. I'll open this schematic page, go to place, and you can click on the path, and I would like to search for the register component, which I'm going to use it. So we have the libraries, so you can use the register library. We have it here, so you can see that these are the register libraries. So these are the existing, which is already available in the tool, are available here. So you can use these libraries and you can utilize that inside your schematic, and you can create a proper circuit. So this is one way, so you can use it from the existing libraries. The second thing is you need to download it, and you can use it if you don't have any library. For example, I would like to take you through one website where you can download the symbols. So we'll go with Snap EDA. So make sure that this particular portal, so you have to register it and then log in. I'll open this. I already logged in. You can see here I have already logged in, so we can search for the component here directly. So I'll come to the search box here. I will write register. So otherwise you can, if you know the part number, you can write it. Like I will write 2512, or it is 6332. That part numbers you can add it and check it out. So we have the list here, and you can see the data available here. The first one here is the data sheet, the second one is the symbol, the third one is the footprint, and the fourth one is the 3D model of the component, and the fifth one is a simulation model, which is not available because that's why it is de-highlighted. So we can take anyone, so just I'll pick the second one. We'll open this particular link and you can see that the symbol here, this is a symbol preparation, this is library, and this is a footprint. And for 3D model, just click on this 3D model and you can get the 3D model under 3D section here. So this is a 3D model, that is a step model, and we can download it if required. So we'll go to symbol here, and inside the symbol I would like to download symbol and footprint. Click on this and it will ask you which tool you are looking for. So earlier I have already selected this is OrCAD and Allegro tool. So if you are freshly downloading any component, it will give you the list of the software, so where you can choose the particular software and you can download it. So we'll go to download sections, click open here, and we have the zip file. We'll just unzip this, right click here and go to WinRAR and unzip this one. So we have the fresh folder which is extracted from the zip file. Open this folder and we can see the many files here, and we are looking for the OLB file. So this is the OrCAD library file. So this one we need to locate it in your library. So we'll just, this is in a desktop downloads. So we'll go to this OrCAD and go to place part, and we'll go to library section here. This is the library section. So the first one is refresh, second one is the add library, which we have downloaded. I would like to click on add library. So we'll click on add library. Now we'll go to downloads. We have this folder, double click, and we have the OLB file. You just select this OLB file and click open, and that library will be updated. Here on the right side you can see that particular library is updated. So now you can see this is the library inside, which is selected, which is we downloaded, just located this, and inside that we have only one component. So you can double click on this component and you can bring that particular symbol inside the schematic page. So this is how we are downloading the library from the third party websites and locate that in your library area, and you can use that. First one, which we have taken it from the existing library. Second one, we downloaded from the internet and we located here. The third option is you need to create on your own. So what I'm going to do is I'll just create one small register. So click on the .dsn file on the left side. So first I'll save this one and go to file here, go to new, go to library. So now you can see there is a library folder. So inside that we got one library1.olb. I would like to save this particular library wherever you want. I'll click on save. So I would like to save this in the folder which we have created, that is switching project. Inside that we will create a new folder called library, that is particularly a symbol library. Open this, and here I would like to give the name, that is switching project library. The .olb that represents OrCAD library. Save this. Here you can see in the left side the library which is created by us. If you right click and add the component, right click here, add new part. So I'll give the name of the component here. The name of the component is register and prefix will be R. Click OK. So you will get some working area. So the dotted line you can see that is working area. The R question mark is a reference, and here we can add the value. So we can go to place here a line and you can draw zigzag line. So click here. I'll take zigzag line within that particular box. Right click and here one is enough. So select control and then select So both segments were selected. Now you can use Ctrl C for copy, Ctrl V for paste. Select here and again you select. I just use 4 zigzag lines and then we'll reduce the working area. I'll reduce the working area from top as well as from bottom side of the symbol. So I'll keep this register somewhere here and I'll keep the value somewhere here. Now we need to add the 2 pins. Go to place here and choose the pin. So we'll take pin name as 1, number as 1, keep it live, line, passive and click OK. So pin number 1 on the right side, pin number 2 on the left side. So if you want to reduce the size here, you can select this particular pin. Go to edit pins on the right side. Here we have the edit pins on the right side. Click on the edit pin, and if you don't want, you just have to select this line and reduce this to short and click apply and then OK, and you can see that pin number 1 is reduced. The size of the pin is reduced. Similarly, you can do the same thing for pin number 2, and here instead of line, double click here and you'll get this drop down, and here you can choose short, apply and then click OK. So both pin sizes are reduced now. So if you don't want to see this pin name and pin number, we can hide it. On the right side, you just come here and drag this particular panel, and here we have got 3 options, that is pin name visibility, pin number visibility and pin name rotate. These 2 we will uncheck it, so those pin numbers will be hidden from the visibility. So now I'll just uncheck these 2 and you can see the pin name and pin numbers got hidden. So this is how we are going to create the symbol in creating the library, and inside that we created this particular parts symbol preparation along with the pin properties. So I'll just save this, right click on this tab and save it, close it, and we can use that. So first we'll go to place part here and we'll call that particular library. So make sure whenever you are searching for any component, make sure everything is selected from this library box. So select here, Ctrl A, you press it so that all commodities will come here. Now you can search for the register. I will search for register and make sure that the library name here, you can see the library name is switching project.olb. We also look for the same here inside. So I'll come down. So we have the res, that is register. Come down and you can see the project library name, register switching project. This is what the register under switching project library which we created. So we will use that. Double click on this and you can bring it inside and place it. Right click and mode. So these are the 3 different ways we can collect the component or create the component, and we can update the details. The first one is we used it library, we took it from the existing library. The second one is we have downloaded it from the internet or third-party website, and the third one is we created manually. So these are the 3 ways. So you can create, you can download, or you can use from the existing library of any symbols you want. Okay, so now we are going to use one component and we will download the footprint for that particular component, and we are going to attach that footprint to this particular symbol. So I will remove the other 2. I will use only R1, and I would like to take a package of 2512 to this R1 register, for example, irrespective of whatever the value of the register. So I would like to use the package, so that is 2512 package. We will use it for this particular component. So to a better understanding, we will create our net. So I'll just create a net between this itself, and we'll give one net name. So we'll give that as net and we'll place it here. Okay, so the one component we will switch it initially. Later, according to circuits, we will increase the number of parts, attach the footprints, and we are going to switch it from schematic to board design. Okay, so now the agenda is we need to look for 2512 footprints. So we still have an option to create the footprint, that is manually, that was the recommended option, and you will also have an option to download the footprint from the third-party vendor. Even after downloading, please make sure that that particular component will have the proper dimensions or not. So in this particular video, I'm going to show you how to download it, and for footprint creation and all, you can check our previous videos. So we'll go ahead to download for 2512 package. So I will choose the third-party website, that is SnapMagic, and log in here, and I will type 2512 register and press enter. So this is the package which is 2512 register, so which is having all the information, that is data sheet, symbol, footprint, as well as 3D. We'll open this and we can download the footprint. Just like how we downloaded the symbol, similarly we'll download the footprints. So what I'm going to do is I'll click on the download footprint option here. So the footprint is downloaded, and open the folder. So right click this particular zip file and click on unzip option, extract to, and a new folder will be extracted, and open this particular folder. And what are the footprint files here? So all are footprint files, so you must focus on the files which are having .pad extension, .psm extension, and .drawing extension, and .ssm if any special symbol or different shapes of symbol if you have. So these are the files of footprint. The main footprint here is the PSM, that is package symbol module, is your main footprint. So if you miss the .pad, so you won't be able to use that PSM file. So make sure you have all at least 3 if a normal pad is there. If any special pad is there, we also look for .ssm file. So now you can see here we have the drawing file .dra, we have the PSM file, we have the pad files. So this is again OrCAD library which we have downloaded earlier, that is symbol library. So I'll just copy these things to footprint folders. We will create footprint folders inside our project. Open the project and here right click, go to new and select footprint. Okay, so we will bring that particular files into the footprints. So open this and we'll choose all the file except the OLB, so we can copy it or cut it and paste it inside the footprint folder which is on the desktop inside the footprint. So we'll just paste it. Okay, so now the main thing is this drawing file, pad file, and PSM file. So this is how we download the footprint from the third-party website. So how to assign, we will see. The first thing, how to assign the footprint. So before assigning, we will open the footprint in PCB editor. So we'll open start PCB editor, open the PCB editor. Here in the pop-up, choose Allegro PCB Designer and click OK. Then to open this, we'll go to File, Open, and we'll go to the location where we have the footprints, that is desktop switching project inside the footprint. So here you can see the file type which is board file. Change it to .drawing file. So we always open with a drawing file. Select the drawing file. So we can see that register drawing file is open. Select that, click on open and click yes. Now you can see this particular design is your footprint. So if any changes, if you want, you can do it here. If you want to write anything like a silk screen. If you want to draw any special thing, you can edit it. If you don't want, you can just leave it as it is. So this is what the footprint for that particular symbol. Okay, so we will update the footprint into schematic. To update it, so we need to copy this particular name, that PSM name we need to copy. So this RESC 1005 into 40. So till here we need to copy the name. So I'll just click on this, Control C, or right click, copy this, and go to schematic here. So right click on the component R1, go to edit properties, not edit part, it should be edit properties. Click on this edit properties. So we have the columns, that is color column, designer column. Similarly, if you will have a drag button towards right side, so click drag towards right side and look for PCB footprint column. So here we can see we have the PCB footprint column. So here for R1 reference, so we are adding the footprint name which is from downloaded file. So click here, I'll just say Ctrl V. So this is how we add footprint to the symbol. So this is R1 is a symbol part reference, and this is PCB footprint. We have added the footprint to the particular component. That means, so we have the register, that is R1. To that register R1 we have the footprint which is assigned here. So these are the pin 1 and pin 2. This is pin number 1, this is pin number 2, and this is pad 1, and this will be pad 2. So we will learn about pin and pad matching later. So this is how we download the footprint, and we attach the footprint to the symbol which is there inside the schematic. So once you attach the footprint, so go to apply here, click on apply, and on top of this right click, save, right click, and then close it. Now you can see this particular part has footprints. If you double click on it, you can still go to the same properties. These are the properties, come towards right side, and you can see the footprint location where we added the footprints. You can also add other options like other properties in bill of material preparation. So this is the minimum requirement for switching the PCB. So we have created symbol, we have used or connected wires for making a dummy schematic. We also added net name. Along with that, for this particular component, we downloaded the footprint which is 2512, and we attached that particular footprint to this symbol. Okay, now we will discuss about how to download the 3D step model for this particular footprints. So we just recall whatever we have done till now. So we have downloaded the symbol, or we have created the symbol, or we have used the existing symbol from the library, so which is the symbol R1, and then we have downloaded the footprint from the third parties websites, that is 2D footprints we have downloaded, and we have attached that particular footprint to the symbol which is in schematic. Now we will download the 3D model. So this will be the 3D model. After downloading from the third-party websites, we will attach that 3D step model to our footprints. So all three will be attached indirectly, so that whenever we switch this particular symbol to board, on the board we will see the footprints. If we switch that particular board to 3D board, we can see the 3D models of the components. So our next objective is to download the 3D model, attach the 3D model to footprints. So these two parts have already done. So the next is download 3D and attach it to the footprint. So we will use this R1. We'll go to the same location where we have downloaded our symbol as well as footprints. So here we have the 3D step model. Click on the 3D model, and we can see this 3D model is here, and you just click on the 3D model download here. Click on 3D model download. So go to the download options. You can see that downloaded file is here, that is 3D step model. So if you want, you can rename it. So I'll just copy this and put it in one more folder where it is 3D step model we have created. So for example, so we have the schematic, we had library folder, we have footprint folder. You can even add the step model inside the footprints, but we'll create one more folder for 3D models. So open the 3D model and here you paste the 3D model. So I am attaching this particular 3D model to schematic, that is R1 component. So I'll change the name to R1. So this is how we download it, and we will attach it to the footprint. So we will open the footprints that which we connected to the R1. So go to PCB editor, select the Allegro, click OK, go to file here, go to open, and we'll go to the project which is footprint. Select the drawing file, and this is the footprint. We attach it to the symbol R1. Okay, so to this footprints, so we will connect the 3D model. To connect the 3D model, go to step and select step package mapping, and here we have the windows. This is for 2D, that is actual the footprints, and this is the area where we need to add 3D model. For adding 3D models, we have the 3D location here. Find out if you have R1 here, otherwise you can go to path here, click on the path, and here inside this path you need to copy paste the downloaded 3D step model. So remember this path which is there inside the C drive where you installed your Cadence, and this is the share local PCB and step. Inside the step folder you need to copy your 3D step model. We'll go to file. So inside the 3D step model we have R1.step. We'll copy that and we'll go to C drive. We'll go to Cadence and we'll go to SPB 17.4. We'll go to share and then we'll go to local PCB, and inside PCB we'll go to step. So open the step, copy paste your R1. So here R1.step is there. We'll close this and we'll go to this particular path. We'll reopen this, go to step package mapping, and now come down here and check out for R1. This is R1. Select the R1 and we can see here on the right side the 3D model is opening. So we will do overlay. Click on the overlay button so that both will be overlapped, and I would like to hide the board so we can see the footprints properly. Zoom in, and now we can do some adjustment and we can place it properly. So symbol, you can make it both, or you can take it only step, and you can also have none options. Anyone you can choose. So I'll just uncheck the, here we have the box for step color. This is the overlay. Okay, so we'll go to view option here, go to top, and now we can do some arrangements here. So if you go to front left, so we need to rotate this. So we'll check with 90 degree on x-axis and we'll go with the top view. Yeah, so you can see that this particular 3D model is exactly pasted on the footprint. That's enough. You just click on the save option here, click on the save, close it, and if you want to cross check, save the footprint also. And here we have the 3D option. Here you can see that 3D option. Otherwise you can go to view and you can also see the 3D canvas. If you open the 3D canvas, it will show you that particular footprint has got 3D step model. So this is the 3D step model which is connected to your footprint, which is placed on your footprint. So you can check with different isometric, and you can also check with top view, bottom view, and you can check with the back view. So you can see here the footprint and 3D model were updated. That's it. This is how you are supposed to download the 3D footprint of the particular 3D step model for the particular footprint and attach it and save that step model which is attached to footprint. So now we are going to discuss about pin to pad mapping. So we'll have a brief explanation about pin to pad mapping. For example, if you have taken the symbol that is register symbol and that has got two pins, that is pin number 1 and pin number 2. Its name is also pin name 1 and pin name is 2. Name is not that important. If name is just for your reference, you can use it, but pin numbers are very important while you are switching to PCB. We have the footprint, that is SMT footprint, and it has got its solder pads or pad of the component. So the number, the pad should be like match with the symbol. Okay, so this is the pad 1 and this is the pad 2 and footprint. So this is actually where your component will be connecting all the connections according to a schematic. So in symbol, for example, if this is R1, the pin 1, so the pad should also have, that footprint pad should also have the pin 1 and both should match. Similarly, if this is pin 2, there should be a pin 2. Sometimes what happens while creating a symbol, by mistakenly we may give pin number 2 and 3. It is just a human error. So then the pad will be 1 and pad will be 2 in the footprint, so those two will never match. So the first pin is not going to match here, and the second pin number as well as pad number will not be matching. So this component will not be allowed to place on the PCB. The switching will happen, but placement on the PCB board will not happen. So the pin to pad mapping is very important. So now we are going to discuss about pin from the schematic part to pad from the footprint should match. So pin to pad matching, we will discuss how do we do that. So I'll open the schematic here. So I'll just right click on this particular component. We'll see what is the pin number here. So this will be 1 and this will be 2, but we will cross check by right clicking on the component, click on edit part, and so this is the component. I just select this top pin and come right side, and you can see that pin name and number here. So pin number is 1, and I'll go to the second pin and you can see that pin number is 2. Otherwise you can go to edit pins and you can see that so you just click outside and select the edit pins here, and you can see the pin numbers here. So the pin number is 1 and 2. We expect the same pin numbers in footprint also. We'll open the footprint and then we will cross check. So go to PCB editor and open the footprint which is attached to this particular component. So we'll go to Allegro PCB Designer, click open, OK, then go to file. Okay, so this is the footprint. So we'll just reopen it again. So this is the footprint under switching project under footprint. So this is footprint which is attached to component R1, and I'll open this. Okay, so we'll see that info button. We select the info button here, that is show element. Click on the show element and click on the first pin, and you can see the pin number here. So just zoom in here and you can see the pin number is 1. Okay, so and then next we are going to we'll click on the pin number 2 and we'll see that is number is assigned as pin number 2. Now you can observe the symbol as well as footprint both have the same pin numbers. The symbol which is having pin number 1 and pin number 2 are matching with pad 1 and pad 2. So sometimes what happens while creating the footprints, by mistakenly we'll give 3 and 4, so then the third pin is not matching with the symbol and fourth pin will not match with the symbol. So switching will happen from schematic to PCB board, but on PCB this component will be rejected on while placement. So this is what pin to pad mapping. So always make sure that even if you have a 2-pin connector, 1-pin connector, 2-pin connector, or 1-pin component, 2-pin component, or n number of pin component, make sure your pad number as well as pin numbers are properly matched. This is all about pin to pad mapping. So here in this case the symbol as well as footprint have the pin to pad mapping. Now we will discuss about switching from schematic to PCB board design. So we have performed a schematic preparation. We have downloaded the footprints, we have attached the 3D model to footprint, and also we have cross-checked pin to pad matching. So everything is fine. Now we will discuss switching. So before going to switching, we will understand how does it works. So first thing what we did is we have prepared a schematic. So this is our schematic. Okay, so for example we have one component and then we have wiring, that is net, which is connected like this. Okay, so this component is reference is given as R1, which is SMT component, and this is what the net name, that is net. So this is our schematic. So apart from this schematic we have prepared footprints, and we kept that particular footprints in a footprint folder. So we kept those footprints in footprint folder, and this is the SMT footprints. So till now we did, and we also cross-checked the pins and pad mapping. So that means here we have the pin 1 and pin 2, and this is matching with the pad 1 and pad 2 of the footprints. So this much we have done. Now we have to shift this entire design to board design. So to shift to board design, first we are going to create a board file. So this is, we call it as board file. So inside the board file we will define the board shape. So board shape can be anything. For example, this might be my board shape. So this is your board shape. For example, this is my board shape. Okay, so now what we need to do is we need to switch this schematic into board. So this entire process is called switching from schematic to PCB board. Okay, so before switching we need to create a board file and board shape, but we also need to export the footprints as well as the nets which we have. So, okay, this is a symbol will be replaced as footprint on PCB, and nets are replaced as rats on the PCB. So now this particular component has a connectivity, the footprint connection to the symbol. So this is footprint connection to the symbol. We have assigned it in edit object properties. So that means this particular symbol will fetch the footprint from the footprint location, which we have assigned in the edit object property. Similarly, we need to export the information about the nets. So we will export the information about the nets. So this is called net list. We will create the net list. So that means the net information. So we have one net here, that one net will be exported to the net list folder. So that is, we have only one net, so that net will be exported to the folder net list. So this is called creating the net list. So we have both symbol will be replaced as footprint. So footprint is attached to the particular component, and the nets are exported, and once we create the board we will import the net list. So once we import the net list, So the symbol will be replaced as footprint along with the pin information. This is pin 1, pad 1 and pad 2, and nets are imported from the net list, and that is called as RAD. So this is what switching process. So the things what we have done is we have done the schematic part. We have created the footprint or downloaded the footprint and attached it to schematic, and now we need to do this part. So that is the third part, which is creating the net list, and later once we create the board file we will import the net list. So where we need to store this particular net list, this net list must be stored in a schematic folder. Always remember, you can save it in any location. So the best practice is make sure the net list is created inside the schematic folder. So this is what the switching basics. So we will now create the net list and save the net list files. So go to schematic here and select the DSN file, go to tools and click on create netlist. So once I click on create netlist, I'll get a small pop-up here. I will choose Cadence and I will choose a folder with the folder name is Allegro. Inside the Allegro folder the netlist will be saved or exported, and this Allegro folder will be there inside the schematic folder. So by default it will be inside the schematic folder. So if you want, you can choose this browse button and you can change the locations wherever you want. That's it. Just click on this OK button and you just have to create the Allegro folder. Click S and the create export. Creating the netlist is done, and you can see that in output folder here. So we got 3 different dat files. These are the netlist files. So we'll go back and check it in the project folder. So we'll go to switching project. Inside that we have schematic. Inside the schematic we will find the Allegro folder. So you can see this Allegro folder. Inside the Allegro folder we will find the netlist logs and netlist files. So these are the netlist related files which are exported from the schematic, so which we will import it in a board once we create the board design. So this is all about creating the netlist, exporting the netlist from the schematic and save it in particular location. Later we will import netlist as well as footprint in board file. Let us discuss about creating the board file. So we have done with the schematic preparations. We have downloaded the footprint and attached this particular footprint to this component, and then we also downloaded 3D model and which we have attached it to the footprint, and then we have discussed about how to create the netlist and what are the elements in the netlist. So now to switch to the PCB board, we need to first create the board file. Inside the board file we need to add our board shape or create the board shape. So once we create the board shape, we can import the netlist from the exported file, and then we will see that footprint on the board file. So this is the overall procedure of switching from schematic to PCB. Our next target, our task is to create the board file. So to create the board file, so we will first create the folder. So we'll go to the project location. So this is inside the switching project. Open this and we have the multiple folders like schematic, library, footprints and the 3D models. Similarly, we will also create another folder called a PCB or board file. I'll give the name as board. So inside this board we are going to create a .brd or board file. To create the board file we will use PCB editor. Go to start and select PCB or type PCB editor and click on the PCB editor. So once the PCB editor pop-up comes out, we will select Allegro PCB Designer and click OK on top of it, and then we will go to file to create the fresh new board. So we'll go to file and then click on new and say no, and here first we need to select the location of the board, and also we need to give the drawing name and then drawing type. So I'll just select the location here, click on browse, so which is we have created the board file. Open the board file and here we will give the name of the board. I will give that is switching project, and the type extension will be file of type for extension will be .brd, that refers to board file. Click open here and you can cross check now. This is the location of the board, that is under board folder, and then we have the name of the board and the type is board. We should select, make sure it is a properly selected, the drawing type should be properly selected. So select it, board, click OK. So once you click OK, you can see the black screen. This is the area where we can create the board shape. So this entire project, our entire file is board file. If we'll go to file here, click on save, and you can check it out in the command bar. So in the preferred location, so .brd is selected or saved. So this is your board file. So we'll go back and cross check in folder system. So we'll go to folder system and you can see inside the board file, board folder, you can see that switching project.brd is generated. So this is whatever board file. Inside the board file, when we open it, and we can create the board shapes. So before going to board shapes, we will discuss the default settings. Default settings we need to assign. So the first setting will be you need to assign it millimeters, that is units. So I'm going to design the entire board in millimeters. If you are designing the board in inches, you can also choose inches. Whichever units you want to use, you can use that. And second one is adjust the grids. Third one is assign or set the origin of the board file, and we'll have some miscellaneous setups, some other setups we will discuss. Okay, so we'll select to do the default setups. So we'll first go to setup file, go to design parameter. So in the design parameter, we find some display enhancement modes here. So if I add all these, then only we'll be able to see. The first one is plated through holes, second one is backdiller holes, non-plated through holes. If you want to show that in your board file, so we need to select everything on here. So if you don't select, for example, if you are not selecting the design origin, so you will not be able to find out where this origin comes. So we will select everything and then click apply. So this is the first setups, and then second one, you should go to design, and here in the design part you can select the user units. So I'm going to design everything in millimeters, so I will select millimeters, and the size initially I will choose A4 sheet, and where you want your origin, so that extents will tell you. In extent we have two components. First one is width and height of the board area where we can design, and next we have these two, that is left x and lower y, that defines where your origin will come and place. So you can see width is 297 and height is 210. That means this is width of the sheet and this is height of the sheet. So if I select A4 sheet here, in the black screen only A4 size will be activated and everything will be freezed out. So we cannot do any design in any other space except this length into width. So this is about extent. So left x and lower y defines where the origin will come. So origin of the component, if you want to keep it here with respect to this corner, so we need to tell where the origin is. Okay, so initially we'll keep that 0 0 0 0 means that origin will be in this left bottom corner. So this is your origin. So if you want to move it towards right, you need to give on the left x. If you want to give towards y axis, you need to give on the lower y axis. So this is how we make activate. So if you click apply and then click OK, so in the entire black screen only A4 sheet is activated. For example, if this is A4 sheet, we can only create a board file or board shape inside this area. The outside area is freezed and we can't perform any operation in outside area. So how to check this? So we'll go and on the grids, go to setup, go to grids, and on the grids and click OK. Now you can see wherever the grid is on. So this is the grid area, this much is the grid area. So inside is an active area where we can create board shape, we can do component placement, routing, everything will be done inside this area. Outside this area is freezed, so we cannot do any operations inside here. So this is what A4 sheet which we have selected. So this is height and this is width. So inside this, whatever we do it inside this. Outside this, it is not allowed. So this is what the extent that explains in setup, design parameter, and inside the design, that is extent. So we'll move the left X and lower Y. I'll keep it minus 25 and minus 25, and then click apply, and I'll just make grids off, and you can see the origin. Now I'll just zoom in. To zoom in, so you can use mouse pointer and scroll it. You can see this is the origin. Okay, so I'll just off this grids and you will identify where the origin is sitting. So here is the origin. Okay, so that means, so we have the A4 sheet from this corner this way, and we have done minus 25. So earlier the origin was here, we moved the sheet minus 25 on x-axis and lower y, that is minus 25 and lower y. The sheet is shifted minus 25 and then it shifted minus 25 bottom. First it shifted left and then it shifted bottom, that is low. So this is where you can move the origin by shifting the active area or extent area. So from here we can create a board shape, and inside the board shape we can call the components or import the netlist. So these are the setups. So first thing, we go into the design parameter. In display we just make everything is on, and then we'll go to design and select units. A4 sheet, you can choose it. I'll just make origin little bit inside the active area, it is minus 25, minus 25. The next one setup is grids. I'll go to grids, and you keep all the grids as small as possible, like 0.1, it is 4 mils. I'll keep it 0.1, that's enough. So we can do a smooth designing if we keep the lower grid. And the final setup is we need to assign the path. Okay, so usually we need to assign the pad path as well as the PSM path. So you might have remembered about pad path and PSM path while downloading the footprints. We have downloaded these two things, one is pad path, another one is PSM path. Okay, so here why we need to assign the path is the PCB editor doesn't know, PCB editor software doesn't know where is your pads or footprints. So to collect the footprint component, so we use PCB editor. In PCB editor we assign the pad path as well as PSM path. That means indirectly we are assigning footprint path in editor. Okay, so how to assign the footprint path? Go to setups, go to user preferences, and then we'll come to two paths we have here. One is pad path, second one is PSM path. You can see this, first one is pad path, second one is PSM path. So click on this small browse button and we'll go to the footprint location. So we'll select this. If you want you can delete it, if you want you can move top, move bottom. So if once you delete, you can create a new location. Click on the new location or insert, browse now, and go for the footprint folder. I'll select the desktop, switching project and footprints. Inside this we have our pad path and PSM path. I will select that pad path, click OK. Similarly same, the PSM file is also there inside the footprint. So select this, I'll delete this, insert new one, browse this, and we'll go to desktop, go to the footprint location and choose that footprint location and then click OK. So now we have properly assigned the pad path and PSM path. That means now the PCB editor know where the pads are and where the PSM files are. Okay, so click apply and then OK. So now we'll be able to find out where the pads and where the PSM files. So this is about creating the board file and doing some default setups. Then we will see how to create the board shape. We'll discuss how to create the board shape now. So I will choose the board shape of size which is 30 mm in length and 20 mm in height, or you can say 30 mm width and 20 mm height. So x-axis will be 30 mm, y-axis will be 20 mm. So to draw this we need to use add. Inside add we have a line options. Go to add here and the line options we have. Once you choose the line, if you come towards the right side here, you can see we will be having a class and subclass here. So in the class we will choose board geometry, and in the subclass I can choose outline or design outline. So I will prefer design outline. So we'll first create an outline, later we can convert it. So the line lock which is 45 degree, we are creating the rectangular, so the line lock or the line bending degree will be 90 degrees, so we will use line lock as 90 degree here. So the line width we can see we can use 0.1 mm just for a visible width, and we'll make line font as solid. Now I hope you understood about the active class and subclass, line lock, line width and line font. Once you select this, I will click on the origin. I will create the board shape which is 30 mm on x-axis, 20 mm on y-axis, again come back 30 mm and 20 mm back to origin. So to click on origin you can directly click using the mouse click, otherwise you can use the command option we have here, command option. So inside the command option, so we can use x space 0 space 0. X space 0 space 0 represents here x space 0 space 0, that represents x represents the origin, and 0 0 will be this point. That means I am clicking on origin. So press enter here. As soon as I press enter, you can see that the line started from the origin. So now you can see the line is started from the origin. Okay, so towards x-axis it should be 30 and towards y-axis it should be 20 from the previous click. I'm discussing about from the previous click. That means our next command will be ix. ix first will be around 30 mm, give one space and you can take 20 mm. So ix represents the last click, and 30 which is x-axis, and if you give space it changes to y-axis. That means from the previous click x-axis is 30, y-axis is 20. So we'll do that in this command prompt. So we'll take ix space 30 space 20 and then press enter, click OK. Let's zoom out a little bit. You can see now, so this is 30 and this is 20. Again we need to come back to 0 0. So we just press x space 0 space 0, x space 0 space 0. That means which is we are clicking on the origin. Right click here and then, so now our board shape is created which is 30 by 20. So this is the board shape. So board shape where we will see in the 3D, go to a view option and click on the 3D canvas. We don't okay, we found a board shape which is 20 by 30 which is an isometric. So you can go to view options in the camera, you can choose top, bottom and side views also. So we got top, bottom, front view, back view, left view, and if you choose isometric it is just like a 3D model PCB board. Okay, so if you want to add a design outline, you can even convert that into design outline. So we can do that design outline. So we can go for edit, Z copy shape. So it is not actually this shape, so we can use add rectangular board geometry, and we can use design outline. So add rectangle board geometry, design outline. We can choose place a rectangle here. Width, we know that width is 30 and height is 20. So if you want to put it, so I want to click on top of this here. From origin to here, that is y-axis is 30, x-axis is 0. So we can use x space, x is 0, y is 30, sorry, y is 20, then press enter. So this is design outline is created. Now if you go back and check it out in 3D, so the design outline is also, you can see that is overlapped on your PCB. So next thing, we need to use a restriction here from the board edge to restriction inside. So we have got two restrictions. One is a package keep in, second one is route keep in. That means if I want to place the component, all component must be inside the board, and the routing is also must be inside the board. So inside 1 mm from the board edge or 40 mils from the board edge we can use. So that means 1 mm inside. So we need to draw two restrictions. One is package keep in, another one is route keep in. It should be at least 1 mm from the board edge on surrounding. So to create that, we'll go to edit, Z copy shape. So go to the class and subclasses here. I can choose package keep in and all the layers, and we can choose contract. That means contract means inside, expand means outside. These two options you can see. Contract is inside, expand means outside. So I'll choose contract, that is 1 mm offset we can use. So in the contract, I'll keep it 1 mm and click on top of the board outline or design outline. So now you can see a blue color rectangular inside. That means this is 1 mm area. Inside this, it is just like a buffer area. No component, no routing, and no drills are allowed. Inside this, package or components are allowed to place. Inside this, the routing is allowed to do. Say routing we have not yet done, so we can go to edit, Z copy shape. So we can put a route restriction here. Click on the route keep in, contract 1 mm, click on top of the board area, that is board outline. So now we got two restrictions here. The first restriction is package keep in, and the second restriction is route keep in. So this is about the board shape. I'll just click on view and 3D canvas. You can see, so 3D canvas is, I think already it is open. So this is the 3D canvas. We will add copper and we will see that. So go to shape here. I'll take a rectangular shape and we will add edge, that is copper edge, on top of the PCB, which is dynamic copper, and I will choose dummy net because we have not included any net list. So this is what the copper is sitting inside the board. Okay, so here this is, as I told you, it is a buffer area where our clearance area we call it as. So no copper, no component is allowed in this area, 1 mm area. No drills also allowed in the 1 mm area, that is restriction. So now you can see the 3D view of 3D canvas on the board edge. So in this area we don't find any kind of copper or component, and here we can see this is the copper. So this is all about creating board shape, which is rectangular board shape of 30 mm and 20 mm. So this area is 20 mm and this area is 30 mm, and we have got the restriction, that is this restriction 1 mm. That restriction is for component keep in or package keep in or route keep in. So in the green color area you can see that's for component placement as well as routing. Okay, now we are going to import the netlist from the schematic. So you can see here, so before importing, netlist, you can see on the right side in options we have a blank things. If you go to right click on this black screen and go to application mode and choose placement edit, so you should find it blank. If you find this area is blank, that means the netlist is not imported. If you go to application mode and general edit, so we have a different options for general edit, and for application mode placement edit we have a different options for placement edit. So once we import the netlist from the schematic level, we will find out the number of components appeared on the right side because it is under the placement edit. So where we are right now is we have the schematic we have created, and we have created the footprint folder, and we saved all the footprint folder, and then we have exported the netlist or created the netlist in the netlist folder. So this is a folder for footprints, and this is the folder for a netlist which we created. So we have attached the schematic symbol, for example. So this footprints are attached with the schematic symbols, and the netlist, the net information is exported and stored in the netlist folder. Now we have created the board file, so that is .brd board file. Inside that we have created the board shape, which is 20 by 30. That is the board shape. The length and height are 20 by 30. So now we need to import the netlist. So once we import the netlist in our board file, we will be able to see the components, number of components which we have. For example, if we have only one, that is R1, will be appeared in this area. So now we can put that inside the board. So we will see that. So we will import first. We'll bring the board. We'll go to file here. We can go to import option. So inside the import option we have the logic or netlist. Select import netlist. So we can choose the Cadence option here. So we have created from the design entry CIS or capture. You can select the capture software. You can choose place change component always, and here in the directory, import directory, we can choose where is our import netlist. So I'll just browse here and select the netlist location. Go to desktop here. So the netlist are stored inside the schematic. So open the schematic and you can choose this one and then click on import, and we have got some errors here. So we will change the location. So we have saved the netlist in different, which has saved the netlist inside the schematic inside the Allegro. So that is what the difference. Select inside the Allegro, choose it and then import it. So once you import, on the right side you can see the register component is appearing. That means in schematic we have only one register. That register is appearing on the right side, that is placement edit. So this is how we import netlist from the schematic to board level. So now we will see the component placement. Now we'll discuss about the component placement. The component is already imported here and we need to bring that component on top of the PCB board. So we'll recall once whatever the things which we have done. So initially we have created a schematic. So okay, inside the schematic we have the component, that is R1 symbol. That particular symbol has got the net. That net is named as NET, and for this we have already created footprints, and we saved that footprints in footprint folder. We have downloaded the footprint and we saved inside the footprint folder. Okay, so and also we connected that footprint with the symbol which is there inside the schematic. So that R1 we have downloaded the footprint and we saved it. So along with that we have also have one more folder called 3D step model. So we downloaded the 3D and we attached it with the footprint, and footprint is attached with the symbol. So this part we have done, and then later we have created the net list in a Allegro folder. So the net list, which is the number of nets, so this information will be kept in one folder. And apart from that we also created a board file. So this is the board file, that is .brd. Inside the board file we have created a board shape, that is a rectangular board shape, and we have done some settings. So for this we have imported the netlist. Once after imported the netlist, this component is showing here. So if I place this component on top of this PCB board, so we can see the footprint along with the required connection, that is RADs. So this everything is done, the symbol preparation, schematic preparation, netlist is done, and we created or downloaded the footprint, we downloaded the 3D models and attached it, we have exported the netlist, and then we created the board file, board shape, and then we have done the netlist import. And now our objective is to place the component on top of the PCB, and we will check whether that particular component or footprint will place on the board or not. So to place the component, so we must match the pin to pad mapping. So we already know about the pin to pad mapping. That means if you have a symbol that is R1 in our schematic, and then we have the footprint which is having two pads, that is pad 1 and pad 2. Similarly we have pin 1 and pin 2, so we have to match with this pin 1 to pad 1 and pin 2 to pad 2. If these two matches, then only this particular component of footprint will be placed on top of the footprint, on top of the PCB board. For example, if you have this pin number 1 but pad number is 2 here, by mistakenly we have assigned pad number 2. So if this is 2 and this is 3 for example, so both are not matching, so the placement is aborted or not allowed, it will show the error. So we need to check pins and pads are mapping or not. First we will go to symbol and check the pin numbers. Okay, we'll note it, and then we'll open the footprint and we will check the pin numbers. If both are fine, then we can go for placement. So we'll go to the schematic now. So in schematic, so how do we check? You just bring the mouse pointer on top of the pin. So you can see the pin number here, the pin number is 1. Similarly, if you bring the mouse pointer on pin number 2, and you can see the pin number 2 is there. So if you want to reconfirm it, so right click on the part, go to edit part, and so you come on the right side, click on edit pins. Now inside the pins we have the pin number section. So this is the pin number section. So inside this pin number section we have two pins, pin 1 and pin 2. This way also you can reconfirm, or you can select the pin, any one pin. I selected the top pin, and you drag the left side panel a little bit, so you can see the pin name and pin number is 1, pin number is 1, and you can select the second pin here. Now you can see the pin number is 2. So that means the symbol has pin number 1 and pin number 2. Similarly, we will open PCB editor and we'll open the footprint and we will check the pad numbers. Both should match. Pad should also have pin pad 1 and pad 2. So we'll go to file, open, and we'll select the drawing file. We'll go to footprint location. So this is the footprint location, and this is the downloaded footprints, and we'll open this, zoom in, and you can see the pin number which is printed here on the first pin, and this is one second pin. Otherwise you can go to info button. Here on top of this we have got the info button. Click on this info button and click on the pad. If you click on the pad, you can see the pin number of the pad. Our pad number is 1. Now you can click on second pad and you can see the number, that is 2. That means symbol and footprint pin to pin and pads are mapping properly. So this component is allowed to place on the PCB board. So we'll go back to board design and we will check we can place it or not. So we'll bring board on in front of the screen, and on the right side you just click on this R1. If you don't find the component here, make sure you are in a placement edit. Just right click, go to application mode, placement edit. Always remember you need to right click on the black screen here. So otherwise you can go to setup, application mode, placement edit. So if it is a general edit, you don't find any components here, because if you want to place the component you must be in a placement edit mode. So we'll go to setup, application mode and placement edit. Now you can see the component here. Number of components will be listed here. In our case we have only R1. We'll select this R1. Now you can see the component I will place on top of the board here. Right click and done you can do. So this is one component is placed on the PCB. So we'll go to view section and click on 3D canvas and we will cross check how it looks like. So this is what the PCB and the component is placed on PCB. So this is the footprint which is used for soldering purpose. You can see the top view. Go to view camera option and click on the top, and this is the component, this is the 3D, and this is the footprint. So this is about the placement. If you want to change, you can change it. For example, if I want move, select move button and I will rotate it by right clicking rotate, and I will place the component here in this side. Right click and done, and you can go for 3D and you can check it. The component is placed this side. So this is how we switch from the schematic to PCB board. It is compulsory, you need to match the pin to pad mapping. For example, we will change the pin number in schematic. So we'll go to schematic and I'll just edit the component pin numbers. We'll go to right click edit part. So this is pin number 1. I'll just make this pin number 2 as 3. I'll just do some manual mistake. So now the pin numbers are 1 and 3. So right click this, close, update all, and you can see if you have done any small changes also you need to create the netlist. We'll go to file, go to tools, create netlist. Inside the Allegro you need to save your latest circuit updates. So we'll go back to the board and I'll just unplace this component. Right click on the component, make sure you have unplaced this component. So before placing, what I'm going to do is I will import the netlist, that is latest information. So I will import the netlist or logic. We'll select the Allegro folder, so which is inside the schematic, inside the Allegro, where we have the netlist files. Select the latest netlist files, click import. Now we can see error we have, but we can see the component on the right side, but this component is not allowed to place on PCB just because our pins are different. So pin, and this is footprint, pad. So this is pin number 1, but this is pin number 3. This is pad number 1, but this is pad number 2. This is right, but we have the mismatch here. So this is fine. Pin number 1 and pad number 1 are matching. Pin number 3 and pad number 2 are not matching. So now in this case the component placement will be rejected. So we'll see, click on the component R1 and bring inside. We can only see the assembly area. Click here, but that particular component is not allowed. You can see in the command bar the pin numbers do not match. We have the proper error message here. The pin number do not match between symbol and component. Okay, so you have to match the pin numbers, then only the component will be allowed to place on PCB. So this is about whenever you do not match pin and pad. We'll go back to schematic and we will change it back to pin number 1 and 2. So we'll see the pin number 3 will be updated to pin number 2. Right click here, close, update all, select S, and we have done changes. So we need to create netlist. So go to tools, create netlist. We are updating the existing netlist. Go back to board design. So we'll import the latest netlist. So we'll select the Allegro folder. Inside the schematic, inside the Allegro, choose this, import the latest netlist. So now we don't find any issues here. You can see in the command line. So I'll select the component and we can place it on top of the board. What happens if we place the component like one pin inside, another pin is outside? This is clear error. You can see this package key pin error. So this restrictions we have discussed earlier. This is about component or package key pin. If the component is outside that area, you can see the error. So you can see the error here, key pin error, and it is not allowed. So if you see this 3D, now half of the component is inside, another half of the component is outside. So this is clear error, that is physical or design error. So select this component, bring it inside. So we don't find any issues. The only value we can see value, it is, we are not going to print that value, but component it is not allowed. So now you can see the 3D on PCB. So it is properly inside the board. So no issues with the component. So this is all about how to do the placement. We will add another component. So we can just do another copy of the same component here and update the netlist. So what I'm going to do is I'll just copy the R1 and paste it. I'll keep it here. So on the right side we got second component. So here I'll delete that netlist. I'll connect this net to here, and that net I'll connect it here. So now we got the two nets. This is net, I'll change it to net 1, and this net I need to change the name. Select this wire and I will name it as net 2 and place on top of this. So now we got the two components, that is R1 and R2, but we used the same thing. If whenever you copy the existing component, the footprint will also copy it automatically. So double click on this R2 and you can go and check the footprint section here. PCB footprint is already selected because we just copied it, so it will take the same copy of the footprint also. So now we will save this and run the DRC before going for. So go to PCB Design rule check. So we'll do some electrical as well as we'll select all. So we have not done rule checking, so we'll do both electrical and physical rule checking, electrical and physical rule checking. So if you choose online, so while designing itself it will show you. Okay, it will also ask for the reports, for electrical reports and for physical reports. Physical, whenever we add the footprint. Electrical, before adding footprints we can run it. Apply this and click on run. So in the output folder, and see in left side in the output folder we can see the DRC result. Double click on the DRC and we see we don't find any issues. So we have got all DRC clear. Now we can go for creating the netlist. Go to place or tools, create netlist, and in the same Allegro folder, so we'll generate the netlist, that is latest netlist, which is having two components and two different nets, and the two components will have same footprint. It is copied and it will also copy the 3D model. So netlist is created here. You can see in the output folder netlist is created, and we'll go back to the board. See, in board we don't find any another component now, so we need to import the latest information. So we'll go back to file and then import netlist. So we will choose the netlist location which is inside the schematic, which is inside the Allegro. Choose that particular folder and make sure it is selected by default. Click on import and we will see another component, that is R2. You can see on the right side R2 is also entered. So I'll select this particular R2 and bring it inside. We will have some connections. Okay, so right click here and and we can save this. Now we can see that in 3D model. So you can see two components are placed. We just copy pasted it, so you can see both at the same times. So you can also change the placement. For example, so okay, if you want to move any component, click on move, and you can go to find. You can only see the select the symbol option, so you can only right click and rotate. I'll place this here, right click and rotate. I'll place this like this. Okay, so these are the two components, and we'll see how it looks like on PCB. On PCB, these two components are placed this way. So this is an isometric view, and we can also see top view, and also you can see side view. Front view, you can see the component height. Isometric, it's 3D view. So this is all about component placement. Now we will download another component, that is through-hole component, and we will switch to PCB. So to that, I will go to the browser and I'll look for the through-hole component, which is 2-pin connector, and this is the symbol which is having 2 pin, and this is the footprint ready. And also we have the 3D model, so it looks like this. 3D model is loading. So this is the 3D model. So we will download the symbol and footprint, and we will update that particular footprint to the component, and we'll download the 3D and we'll attach the 3D to this footprint, and then we will switch to PCB. So I'll just click on the download symbol and footprint. Now the files will be there inside the download folder. Okay, so we'll go to this and open the download folder. We have this library. It has having symbol as well as footprints. We'll just right click here, unzip and open the folder, and we can see we got the pad files, we got the PSM, which is actually the footprint, we got the drawing file, we can edit that footprint, and we have the OLB file, that is OrCAD library. I would like to copy this OrCAD library, and I will go to the project location. So inside the project location we have the library folder. I will just paste that particular library here. So we got this library, so we will add that into our schematic. So we'll go to the schematic and I will click on add place part, and we'll go to right side. We have got the libraries. Click on the library, add library icon, and we'll go to our personal library folder. Inside our project, open the personal library, and we got this newly downloaded symbol, that is library OLB file. Click open, and we have the connector symbol. So double click this connector symbol, so you can keep this inside the schematic page. So we will connect this to the existing circuit. I'll just move right side and I'll place it somewhere here, or you can rotate it by pressing R, and you can keep it this one. Yeah, I'll delete this wire and we'll connect the wire this way. Okay, so now we need to add the net name to this particular net, because we already have a net 1, net 2, and here we'll take net 3 just for our reference. We'll take net 3, place on top of this. So this is the connector, just leave it as it is. So we have updated our circuit. So this is our circuit. We'll just zoom in. Okay, so right click end mode. The component is added, and remember that pin numbers, pin names here, pin names are 0102, pin number is 01 and 02. So it should be same in our footprint also. So we already downloaded the footprints. We'll go to the downloaded folder, or yeah, we'll go to downloaded folder. So here inside this folder we have the footprint files, that is pad files, PSM files, and drawing files, and other supporting files. We'll copy those things and we will put that inside the projects library, go to project folder, we got footprint library, so I'll paste this here. Okay, I will just copy the PSM name, select this particular component and copy this. We'll go to schematic and double click on this component and we'll jump to footprint location. It's already connected here, so just I'll update that same thing. Okay, so this is the footprint, that is PCB. PSM file is attached, so we'll click on apply and right click here, save this. Okay, so now we'll open the footprint and we'll attach the 3D. So we have not downloaded the 3D, so we'll open the footprint first and we'll check the pin and pad numbers. So we'll go to PCB editor, select Allegro PCB Designer, click OK, then go to file, open. We need to open the drawing file, select the file of type is drawing, we'll go back to footprint location and this is the drawing file for connector. Open this and this is your footprints. Okay, we'll go to I button, you can select show element button, click on the first and you can see the pin number is also 01, so no need to change anything here because the pin number in schematic symbol is also 01, pin number in pad is also 01, so both pads are matching, and this is 02. In schematic also we have the pin number 02, so no need to change anything here, just save it as it is. Now we need to download the 3D and attach it to this. So before checking the 3D, we'll go 3D canvas and we don't find any 3D here, we just have the through pin, that is PTH, plated through hole pin, and the cell screen which is designed. This is actually the footprint and this is the cell screen which represents the pin number 1, which side is pin number 1. So this is about footprint. So we'll go back to the browser and here we'll click on the 3D model. So this 3D model we need, so download this 3D model and this is for Cadence. Select the download 3D model. So we have that in download folder. Open the download folder. We'll just right click here and unzip the file. Open this and we have got the stuff file. This is the stuff file. I will just change this name because it is for our reference. I will just put it whatever the reference we have. We have the J1 reference here, so we'll keep that name is also a J1. Okay, so I will copy this to our footprint folder, 3D model, and paste it here. Apart from here, we also need to update in C drive. So go to C drive and go to Cadence, and here is PB 17.4 tools, not tools, it should be share and then local and then PCB and then stuff file. Double click on the stuff folder, just paste it. J1.stuff is pasted. Now we'll go to footprint. Now we'll attach that 3D to footprint. This is the footprint. We'll go to setup and setup package mapping. Okay, we got the components here, so we will select the J1 step model here. Selected the J1 step model, hide the PCB board, overlay, and we'll make this angle as 90 degree. Press enter. That's it. Just check it out the top side. Yeah, this is properly placed inside the holes, and if you see it from the bottom side, so this is the bottom side. Okay, front left, that is enough. So just save this component and then close this window and save the footprint and go to view 3D canvas. Yeah, this is perfectly all right, which is placed on the footprint. So we can go top view and check it out. So nothing, no difference, no issues. Go to bottom and check it out. See here, the leads are properly inserted into the holes or PTH. Right side. Okay, so this is perfectly placed on top of the footprint, and then we'll close this footprint. Save it. Okay, we'll go to our board. Before going to board, so this is our component schematic. So we will create the fresh netlist because we have only part 1 and part 2, that is R1 and R2 we had earlier. So now we have got some updates inside the schematic. So we will select the DSN file, save it first, and create the netlist. So this is the latest file, which is updated file, updated to the netlist, and we'll go back to PCB board. So inside the board we have two components. Make sure you have the application mode is placement edit. So I will import the netlist. Go to file here, import the netlist, and select the import directory, which is Allegro folder. Inside the schematic we had Allegro folder. Choose that and click on import. Once you import, on the right side you can see the new component. If there is no any issues, so you can see that particular component here. So now if you want to place it, click on this checkbox and you can see the component is coming inside. You can place on top of the board wherever you want. So the connections are also updating, the tracks are coming up, and we'll go and check it out in 3D canvas. We go to 3D canvas, and yes, you can see the third component is placing. The two components which we placed are SMT, and the third one is PTH, that is plated through hole. So this is the way you can create netlist, and when we come back to PCB board, we will import the netlist. So this is very important while switching. Make sure your symbol pin numbers and pad footprint pin numbers are same, should match it properly. So here in this through hole component, that is PTH component, the pin number 1 is named as 01 in schematic, in symbol as well as in footprint. The second pin is pin number is named as 02, that is in schematic symbol as well as in footprint also. So both are matching, so that is why this component is allowing to place on the PCB. So this is about switching from schematics to the board design. If you have any questions, please let us know in the comment box. We will reply you as soon as possible. Thank you so much for your support. Thanks a lot. We have an important update for you. If you guys are looking for a PCB design course from basics to expert level, we have it for you. This is an Udemy course, PCB Design in Cadence OrCAD Allegro, basics to expert level. This course has got 3,800 plus students enrolled and has got 4.5 rating. So this particular course has got 33.5 hours on-demand video and 151 downloadable resources. And also this course has got 16 different sections with 154 lecturers plus counting. That means we are updating classes every day or every week and basis. So if you want to opt to this course, it is just an affordable price. You can go for this. I will leave this link in the description box. If you are interested, please go through it. If somebody else is interested, please share with them. Thank you.